just a couple slides here to talk about domain and maybe a little bit about range of functions or equations or graphs, provided my pen works. We're all familiar with domain. When we have a bunch of ordered pairs, and somebody says, well, what's the domain? Then the domain means the x values, right? Those are domain. And the range means the y values. Okay, and that's certainly true. But when you have a function, right, a function like let me just say this is a parabola, which is y equals x squared. I mean, the graph of the parabola is made up of infinitely many ordered pairs. You know, every point on this line is another ordered pair, and these arrows go on forever. So there's infinitely many points. There's no way to go through a set of points and identify all the x values as the domain and all the y values as the range. And now we need to come up with a different way to think about domain and range. And if you remember, when we have a function, something like f of x equals 2x plus 1, we always think of the x as the independent variable. Because that's the variable you're going to choose to substitute a value for and then calculate using this rule, 2x plus 1, the function value, also known as the y. So y depends on x, and you get to pick the x. So we need to know what x values we can put into any equation of a function. And there are a few particular things that we're going to try to avoid here. And at this point in this class, there's two that we're most interested in. Number one, we do not want to divide by 0. If I ever had something like f of x equals 3 over x minus 2, I would have to say that the domain is x does not equal 2, because if I substitute x equals 2, 2 minus 2 is 0. And now I'm dividing by 0. And dividing by 0 is not allowed. It's not possible in math. So we would say the domain is x does not equal 2. Right? That implies it could be any other number, but it just can't be 2. So that's one situation that we're looking for. The other situation, which will come up because of this section, this chapter that we're in, is we don't want to take the square root of a negative number. So if, for example, I had the square root of, just to be consistent, x minus 2, I know that x minus 2 as an expression has to be either positive or 0, but it cannot be negative because you can't take the square root of a negative number and have that be real. So the way we figured the domain is we would say, okay, well then let's set x minus 2 greater than or equal to 0, because that's what we need it to be, and solve. Add 2, x is greater than or equal to 2. That's the domain. So these two situations, we will forever on after this, we're always talking about the two. Don't divide by 0. Don't take the square root or the even root of a negative number.